Fire History presents Fire Facts with Chiefs Bill Lellis and Paul Smith. Today's episode:
Nozzle News.
If fires are to be controlled or extinguished, the department must pre-plan and be capable of skillful execution. Trained officers are essential. Modern equipment is necessary. But in most cases, the person who actually controls the fire is a key man, the nozzleman.
Good day, and welcome to the Marin County Fire Chief's historical website. Today's subject on Fire Facts will be the development of the smooth bore nozzle. Slide. In the 1880s, the American population was growing at a rapid pace. Between 1870 and 1920, 11 million Americans moved from the farm into the city. Near the close of the 19th century, there was no national standard for apparatus and or nozzles. Manufacturers, and most important, the insurance companies, needed some rules and regulations to underwrite a building and for businesses and homes. Slide. A gentleman by the name of John Freeman, an MIT mechanical engineer, took it upon himself to put into a study on how to calculate fire suppression water for fire protection. And what he invented, we still use to this day. Slide. His invention would become what is called the underwriter's play pipe. It's an instrument that he developed so he could test the water supply. So at the local fire hydrant, we would know how many gallons per minute that hydrant would supply. So the play pipe is been replaced by electronic monitoring devices. But the play pipe itself is about 30 inches long. It's ready for a 2.5 inch national standard inlets. It's got swivels. The swivels are for the gentleman at the hydrant can move the nozzle. The nozzle has a play to it. In other words, you can move it. It's wrapped in a red marlin trim non-slip for the hands to grab it. The first tip is an 1 3/4 outlet, which we'll talk about a little later, but the 1 3/4 tip as a handheld nozzle is something to be avoided. But what came out of this nozzle was that last tip, that 1 1/8 tip. The 1 1/8 tip was the baseline for nozzles in America. And all of this was tested with a pitot gauge. So next slide, please. The most common straight bore tip that the fire service would encounter in about 1914, as you saw in that scene of New York City, the tenement buildings were getting more and more zero clearance between buildings. 3, 4, 5 stories of wood frame buildings. So they came up with an interior hose cabinet, what you and I would call today a class 2 standpipe. It was to be used by the tenants and not the fire department. And it's a very unique situation. In 1914, in order to make it the hose that you're looking at is really a linen flex. It has no rubber lining. What happens is it would you would pull 100 feet of hose off the rack, and you would open the valve, and then the water would come out the smooth bore half-inch tip at about 50 gallons a minute. And what happens with this, it was, since it's linen flex, it would have to get wet and swell up, and it would never become 100% watertight. It was always leaking, but it was to be used by tenants, and it was used to be temporary until the fire department arrived. So, but with the thing, it has no shut-offs. If it had a shut-off, that pressure alone would rip the linen flex. So that was one of the things. A very unique thing now, that came in 1914. And as we all know in the fire service, these appliances are seldom used. I think in my entire career, I only used one of these probably once. But what's the codes are saying now, if a building has this system and the owner wants to remove it, the code's saying, hey, if you were to build that building today and not require that standpipe, then you can remove the standpipe that was put in 20, 40 years ago. It's a very significant change for ownership, building owners not having to pay for that 5-year test. So Freeman's test still stands with us today. Next slide, please. As I mentioned earlier, there were no standards in America. There were many manufacturers. Every municipality could have its own standard, its own type of thread, its pitch. So it was always, so they were pushing it. So between the international fire chiefs and the underwriters, they decided to come up with a nozzle standard. But you can see in the 1800s, a brass nozzle is just a tapered cylinder worth $5. But the average tip in the first time came out like 1/7 tip up to 1.25 inch tip. Now, a 1/7 tip is 160 gallons a minute. And the largest tip that is really should be handheld, nothing bigger, is 1.25 inch tip that flows 328 gallons. That is a lot of water. And more important, it's a lot of nozzle reaction, which means fatigue for the firefighter holding that nozzle. But the 1.1/8 tip at 45 pounds of nozzle pressure can flow approximately 250 gallons a minute. Thus, the standard that we have lived by for over 100 years. The 1.1/8 tip at about 45 pounds of nozzle pressure will produce a little over 250 gallons per minute, and 250 gallons per minute is 1 ton. So the term 1-ton stream is a derivative of this research. Next slide, please. This is the most common straight tips you're going to find in today's fire on the fire engine will be the master streams. The master stream straight tip, unlike the handheld, of course, have a nozzle pressure of 80 pounds of pressure. And they go from 500 gallons a minute to over 1,000. The question we need to ask ourselves in the fire service, how many gallons per minute do we want to flow from an engine? And the power plant that's going to be required to move over 1,000 gallons a minute from a tip. So the fire service today is considering what's the limit to the power plant on a new engine, and what is the gallons per minute we practically can really use. So that's it. Now there is a fog nozzle that comes with a master stream that'll be covered in Chief Paul Smith lecture. Next slide, please. Now it's been well over 100 years since the straight tip nozzle was brought into the American Fire Service. And then we made the transition from a straight tip as technology advances and shut-offs and so forth came about. But a few years back, a grant, and they studied the use of a nozzle and its effect on the firefighter holding the nozzle as a fatigue factor. And we now are going back to our live lines to a 7/8 inch tip. And that flows about 160 gallons. the reaction on the nozzle is manageable by a single firefighter who can, without fatigue and fear of slipping or being knocked down by nozzle reaction. So we now have it over in the county in which I worked, in Contra Costa County. They are making the transitions in the department in which I work for now, the Rodeo Hercules Fire Department. We have made the transition to half the live lines, inch and 7/8 inch tips, single smooth bore. So with that said, that is kind of like the history of, the next slide, please. This is one of the first modern fire engines made in the world. It was made in England in 1725. It was the first apparatus that could both give gallons per minute and pressure. It's a hand pump. It had the bucket, the tub, so to speak, had to be filled with buckets of water. 8 to 16 citizens would pump. The nozzle is a straight tip, single bore nozzle. It can flow 60 gallons a minute. And with good hand pumper, it could throw a stream almost 100 feet. So that was the introduction in 1725, a smooth bore tip. There was no such thing as pressure. The pressure was how quick the citizens could rack those arms up and down. So with that said, so it's going back then. And at this time, I want to thank the Phoenix Fire Museum for the use of this photograph. So the smooth bore tip has come full cycle. Nothing changes, as they say. History has a tendency to repeat itself. And with that, Dan, I'd like to bring the slide up and bring Paul Smith into the picture. As you can see here, this is a combination. One is a straight tip live line. The other one is a combination straight tip fog nozzle. And I think that's where the fire service is probably going to go to in the next decade. With that said, I'd like to bring into the program retired fire chief from Kentfield, Paul Smith, to talk about the straight tip nozzles and his program. That'll be part 2 later on this month. Morning, Paul, and welcome to the show.
Good morning, Bill. That was very interesting. You know, every time we do one of these for Fire Facts or Marin Fire History, you know, I learn something because you do a ton of research on things. I do a ton of research on things, and it's fascinating to look back at a fellow like Daniel Freeman and the work he did in producing or developing standards for fire department use that we're still using today. The physics hasn't changed.
Oh, no. And one of the things we keep forgetting about is how important the insurance industry was. Just a side note, the insurance industry canceled a lot of fires and insurance in Chicago because the city council in Chicago in the 1800s wouldn't pay attention until they had the Great Chicago Fire. And that really brought municipalities in line with the insurance industry. But to this day, what do we do when we test our engines? Their underwriter test comes in and tests the engines, test the hose. They were still with us. They give us our ratings. So the insurance industry played a very important role, in our development. So
and it's you move 100 years forward in today's world, it would be crazy if there were no standards among towns and cities in America today. You could think about it, anything from mutual aid, like we have mutual aid here in California. Can you imagine going to a wildland fire and having 3 or 4 or 5 different standards for hose and for threads or for nozzles? So,
oh yeah, on that same note, Paul, just as I highlight, when I got into business, I came into Larkspur Volunteers in about 1957. And at that moment in time, I believe California was on what we call the Pacific Coast thread, the pitch and angles of the thread.
Right.
And we made the state made an adjustment to the national standard thread.
Right.
So every a company would come in, grab every piece of hose, every nozzle, and change the thread. They could change the pitch without taking the nozzle. And so we went to the national standard thread. And even today in Larkspur, I believe the Boardwalk One still has Pacific Coast threads on the standard system that goes out there, unless they changed it since I've left, which could be. But that's some of the changes that we experienced.
Yeah. And I look back at, you showed a slide a little while ago about the Class 2 standpipe hoses in the multi-story buildings you talked about.
Yeah.
And in my career, we saw some of those Class 2 standpipe systems still in service with a linen hose.
Yeah.
And today, if the building has not been remodeled, but the owner has taken out that hose, a lot of times you'll find the fire extinguisher there, and that old gate valve has been capped off. They don't test them anymore. They don't need to maintain them anymore, but they'll put a 5-pound ABC extinguisher or something in there.
No, and just a note, as you know, coming to the Tamalpais high-rise fire situation, that was like a 13-story building, and we had 5 guys on duty, mutual aid automatic from Kinfield, and we used the standpipes. We did not carry our hose to the 4th and 5th, 9th floor. They tested so well that we used the standpipe as our initial attack. We only had 5 guys. And if you had a fire on the 9th floor waiting for you to come up with the aerial behind it, I mean, so there was a building where we trusted and used the standpipe on a couple working fires at the Tamalpais. But
I remember what was unique about that system at the TAM was they were all wet standpipes.
Yes. Yeah.
There wasn't a dry standpipe system, which is typical or more typical, I think. So they didn't the second in engine didn't have to pump the standpipe system up. They were wet. You take your line to the 5th floor and put your hose bundle on it and turn the valve, and the water would come out.
Yeah. So it's a use. A quick story on that. We had a working structure fire on let's say the 9th floor at Tamalpais. The manager goes to the fire floor, sees smoke, grabs the standpipe, pulls out the 100 feet, turns the valve on, and goes into the apartment and gets driven out by smoke and heat, but leaves the nozzle floating because it doesn't shut off. First in captain's George Rogers. He gets to the fire floor, sees that the hose has been pulled. It's leaking all the way, 100 feet of leaking all the way down, and opens the door just as they enter. Luckily, he had a Scott pack on, and just as he steps into the door, the nozzle comes whipping around and hits him in the helmet and cracks his helmet. He came close to losing both his mask in a hostile environment, and not suffering facial injuries. But those things were dangerous if in the hands of an amateur. So you see why they're slowly being replaced. Yeah. So, but other than that, that's kind of the history of the smoothbore nozzle. And tell us about what you're going to be doing on part 2.
Well, I'll pick up where we left off today next time, and we'll talk about the development and the evolution of the fog nozzle and how that happened. And I hope to tie in some of the pieces that you've talked about today with how fire was fought back in the early days. And it cracked me up this morning with our intro with the nozzle, the film piece, the old training film piece from, I think it was University of Iowa.
Yeah,
that's a great lead-in for the nozzleman. It's fun. So until next time, Bill, do you have anything else? You don't wrap up today, or?
All right. Well, we're just about ready, sir. I wish you lots of luck on your presentation. Take care.
Thanks. And
thank you for
thanks
watching.
Everybody for tuning in to Marin Fire History. We enjoy having you, and thanks for tuning in. And we appreciate the support of Marin County Fire Chiefs to produce this production.